Hello students, today we are going to study a physics topic, that is electricity. You know the importance of electricity in our day to day life, clear? So electricity, what it is? Electricity is a source of energy that has made our life comfortable and easy. We need energy, that is electricity, for performing different day to day life activities. For example, for glowing a bulb, then for running electric engines are there, refrigerators are there, ACs are there, so there etc. So there is hardly any field where electricity is not needed. If in a one day or if in a particular day electricity is not there, we see how we feel, clear? So in today's topic we are going to study about what is charge, what is electric current, electric circuit, symbols related to electric circuit diagrams, electric potential, potential difference, Ohm's law and resistance. So now I will be showing you all this in our slides. Electricity, okay. So we will see the importance of electricity in our day to day life. First of all, see what is electricity. Electricity is a flow of electrons around a particular circuit. So in this circuit, see what is there? A battery is there, lamp is there, bulb is there, and the electrons are flowing from which terminal? From negative to positive, but the electric current is moving from positive terminal to negative terminal, clear? So after this I will be telling you about charge. What is a charge? So here electric charge is a physical property of matter that causes it to experience force when placed in an electromagnetic field. There are two types of charges, that is positive charge and negative charge. Positive charge is due to the flow of protons and negative charge is due to the flow of electrons. As we know, like charges repel each other and unlike charges attract each other. The SI unit of charge is coulomb, which is denoted by the letter C. Okay. So 1 coulomb is that quantity of electric charge which exerts a force of 9 into 10 to the power 9 newtons on an equal charge placed at a distance of 1 meter from it. Clear? So next to that, a proton possesses a positive charge of 1.6 into 10 to the power minus 19 coulombs, whereas an electron possesses a negative charge of 1.6 into 10 to the power minus 19 coulombs. The SI unit of electric charge, that is coulomb, is equivalent to the charge contained in 6.25 into 10 to the power 18 electrons. See here protons and electrons, positive and negative charge, the figure is there, clear? Now after this, conductors and insulators. So what are conductors? So what are conductors? Those substances through which electricity can flow are called conductors. All the metals like silver, copper, aluminum, etc. are conductors. So in our houses also what happened, we are using copper wiring is there that conducts electricity from one place to other, okay, as it is a good conductor of electricity. So next to that, those substances through which electricity cannot flow are called insulators. They are glass, rubber, cotton, mica, bakelite, porcelain, etc. See here some figures related to electrical conductors. It is shown. First of all, conductors silver, gold, copper, steels, okay, and then insulators are rubber, glass, oil, diamond, dry wood, etc. These are all insulators. After this we will be studying what is electric current. So what is electric current? An electric current is defined as the amount of charge flowing through any cross section of a conductor in unit time. So let us see, let Q be the charge flowing through a cross section of a conductor in time t, then the electric current is given by the formula electric current equals to charge upon time. Electric current is indicated by I, charge is indicated by Q and time by T. So I equals to Q upon T. The SI unit of electric current is ampere, clear? So here we will define what is ampere. So 1 ampere equal to 1 coulomb upon 1 second. So 1 ampere, what is 1 ampere? So here electric current is said to be 1 ampere when 1 coulomb of charge is flowing through any cross section of a conductor in 1 second. Then smaller unit of electric current are 1 milliampere equals to 10 to the power minus 3 ampere, and 1 microampere is equals to 10 to the power minus 6 ampere. Electric current is a scalar quantity. So here electric current is measured by an instrument known as ammeter. An ammeter is always connected in series in an electric circuit. See here, ammeter is there. This is an instrument. That red button and black button. One is indicating a positive terminal of ammeter, other one is the negative terminal of the ammeter. Always remember, the positive terminal of the battery is connected to positive terminal of a ammeter, and the negative terminal of a battery is connected to negative terminal of ammeter. Clear? So this is an instrument which is used. See the positive negative charge, see the battery positive terminal and then negative positive of ammeter. Similarly, positive for negative for battery is connected to negative of ammeter. Clear? So remember one thing, that ammeter is always connected in series. Next to that we will be studying electric circuit. So what is electric circuit? The closed and continuous path through which the electric current flows is known as electric circuit. So in this what happens, there are two types of circuit. They are open circuit where no electric current flows, and then closed circuit where electric current flows continuously. Clear? See the circuit diagram. The diagram which indicates how different components in a circuit have been connected by using the electrical symbols for the component is called electric circuit diagram. Here open circuit and closed circuit. So here are some of the symbols related to circuit diagram. So first is electric cell, then battery. So what is battery? Combination of cell is called battery. Then open key, then closed key. So here a wire joint. Clear? Then electric bulb, variable resistance, ammeter, voltmeter, galvanometer, etc. These are some of the symbols which are used to make a circuit diagram. Now next to that we will be studying about electric potential. What is electric potential? So in this what happens, it is the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. It is also a scalar quantity. The SI unit of is joules per coulomb, or it is also known as volts. So here see the diagram. Here one point is there infinity and other point is there. The work is done by moving a charge from infinity to that particular point. Clear? So here potential difference. So what is potential difference? It is the amount of work done in bringing a unit positive charge from one point to other in an electric field. It is also scalar quantity. Okay, the SI unit, it is joule per second, or it is also known as volts. So it is responsible for the flow of current in a conductor. The formula for potential difference is potential difference equals to work done upon quantity of charge moved. So here potential difference, it is indicated by V, work done by W, and quantity of charge moved by Q. So V equals to W upon Q. Clear? Where W is the work done, Q is the quantity of charge moved. The potential difference between the 2 points is said to be 1 volt. If 1 joule of work is done in moving 1 coulomb of charge from one point to other. So here it is given 1 volt equal to 1 joule upon 1 coulomb. Here the potential difference is measured by an instrument called as voltmeter. See the voltmeter is there, and this voltmeter is always connected in parallel, okay, across the points where the potential difference is to be measured. Clear? So it is always connected, that ammeter is connected in series and voltmeter is always connected in parallel in the circuit. Clear? See here A and B are the 2 points. Okay, between these 2 points we will measure the potential difference by means of a instrument known as voltmeter. Then comes a very important, that is Ohm's law. So in 1827 a German physicist George Simon Ohm found out a relationship between current and potential difference. So, he stated one law that is known as Ohm's law. This law has given the relation, as I told you, between current and potential difference. The law states that at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its ends. Clear? If I is the current flowing through the conductor and V is the potential difference across its end, then according to Ohm's law, V proportional to I, or it is also written as I proportional to V. V equals to IR, where R is resistance constant, or you can say constant called resistance. So, R equals to V upon I, where V is potential difference, I is current and R is resistance. So, V equals to IR, or we can write I equals to V upon R. Clear? So, see the Ohm's law circuit diagram. Here it is Ohm's law circuit diagram. Clear? So, in that it is containing what it is having? Ammeter is there, voltmeter is there, battery, okay, resistance, etc. So, again here the VI graph for Ohm's law is a straight line passing through the origin. Along with the law we can write it down. So, I equals to V upon R. Clear? So, resistance of a conductor. So, what is resistance? Resistance means to oppose. Okay. So, what is resistance of a conductor? Resistance means to oppose or to resist the flow of charges through its conductor. So, resistance is equal to potential difference upon current. So, R equals to V upon I. Okay, the SI unit of resistance is ohm, 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 which is denoted by the sign omega. Clear? If the potential difference V is 1 volt and the current is 1 ampere, then the resistance is said to be 1 ohm. 1 ohm equals to 1 volt upon 1 ampere. So, 1 ohm is the resistance of a conductor such that when the potential difference of 1 volt is applied to its end, a current of 1 ampere flows through it. See, the formulas are there which are very important for solving problems. Clear? Then what is rheostat? So, variable resistance is measured by an instrument known as rheostat. We can change the resistance by moving this rheostat. Clear? So, next, factors affecting resistance of a conductor are, first, that is length of the conductor. Resistance is directly proportional to the length of the conductor. If the length of the conductor is more, resistance will also be more. If the length of the conductor is less, resistance of conductor will also be less. Means what happens here? R proportional to L. Second factor, that is area of cross section of a conductor. Here resistance is inversely proportional to area of cross section of a conductor. Means if the area is more, resistance will be less, and if the area is less, resistance will be more. Okay. Now, the third factor that affects the resistance of a conductor is nature of the material of the conductor. What type of nature it is having? Different materials are used, like copper wiring is there, then aluminum wiring is there, silver wiring is there. According to that, what happens? Resistance is there. And the last one is temperature of the conductor. So, these are the 4 factors on which the resistance of the conductor depends. So, I hope so it is clear to you. So, thank you.